Alright, so in this chapter we're going to talk about functions and a lot of different vocab, and I just want you guys to be familiar with what this vocab means before we really get into this nitty-gritty stuff. Am I ever going to make you guys memorize definitions? No, but I definitely want you guys to know what they mean. So, starting off, a function is just something that is one-to-one. And what that means is that every x has its own unique y value. And what that means is that basically this sentence gets repeated a lot without any real explanation. So what that means is that there are no x's repeating. With a different y value. Alright. Functions can start off two different ways. They can start off as a y equals, or more commonly nowadays, it's that f of x is equal. Just meaning a function of x is all that means. Alright, the domain is just the set of all of your x's. Range, likewise, is the set of all my y's. Vertical line test is just literally where we look at a graph and we draw a vertical line straight up and down where we think that that vertical line will touch the most points on the graph. And if it intersects the graph that we have in more than one point, then that means that it is not a function. So I shouldn't abbreviate point yet because some of you guys haven't had me before. Yeah, and a lot of times I abbreviate point as PT. Okay, so what this means is if I have a graph that looks like this, let's say that's my x and y axis. I don't want to draw my vertical line test clear over here because then be like, okay, it only touches in one point. That's a function, right? No, make sure you draw your vertical line, where it can touch more than one point if it looks like it's going to touch more than one point. Alright, so what continuity means is graphically that means that you should be able to graph your function continuity means that you should be able to graph your function with one continuous pencil stroke, and that's it. So continuity or continuous functions is definitely more common now in Precalculus than it is in, for example, Algebra 1 and Algebra 2, because in Algebra 1 and Algebra 2 you guys were definitely graphing just points randomly, and then you guys would connect them and be like, okay, that's my graph. Like, okay. But then you'd have some strange point over here and be like, it's not continuous because there's that one point that's not connected. Or even if you still had that just that graph, it would be discontinuous. discontinuous graphs are definitely used in finite a lot more than anything else in statistics. Alright, let's talk about the 3 restrictions of domain. So there are 3 restrictions of domain. They are broken down into 2 different groups or subsets, and that is removable and non-removable. So removable is just going to be listed under holes, which we will talk about later. So what that looks like is basically when we have some graph going along, all of a sudden there's this one value that just doesn't work out. And then the graph just continues. Well, that's cool. Alright, so now non-removable. There's actually 2 non-removables, and that would be jumps, which is where we've got a graph, and all of a sudden it takes off, and it picks back up over here, and it'll literally just jump on over randomly. So those are most common with the functions that look like f of x is equal to, and then you got that weird curly bracket, x when x is greater than 0, and then x minus 3 if x is less than or equal to 4, for example. Or even just less than or equal to 0. And those are what we call piecewise functions. Alright, and then there's something else called infinite discontinuities, which are more commonly known as asymptotes. So asymptotes are usually represented by dashy lines, and they are particular values that we actually can't touch. So the most common graph that has an asymptote is probably the graph like y equals 1 over x, or f of x is equal to 1 over x. We will talk about asymptotes more and more, but if you have a dashy line going this way, it's x. On your x-axis, it is that y equals, and if you have a dashy line going this way, it is an x equals line, even though that is your y-axis, because all of your x values stay the same on this line, and all of your y values stay the same on this line, hence why it is a y equals. Alright. Increasing functions is just... oh, jeez. It's where your x values will go up. That was interesting. And your y values will go up. Alright, similarly, your decreasing function will have your x values going up, but your y values will go down. Alright, constant function is where your x values will go up, but your y values will stay the same.